Trig review part 2. So let's start with some basic graphs. So first thing to know, our amplitude is always a number of fronts, which in this case, if I can get this right, is a 1, right? There's a number of fronts, so it's 1. That's how high and low you go. Principal axis is kind of where you start, so we should always start at the middle, 0, unless we have to move it up, which we'll talk about in a bit. And the period, there's a formula for it, it's 2 pi over b, where b is the number from your x. So this case, both these cases 1. We're doing a very basic graph here. So 2 pi. So let's go back to this graph here. So basic sine graph, right? In this case, where my amp is 1, period's 2 pi. So this will be 1. Go up to 1, go down to -1. Period's 2 pi, so I'm going to end right here at 2 pi. And the way you graph a sine function is you start at the origin, end at your period, 2 pi. Halfway in between is the middle. Is where you cross. Halfway between these two is your highest point. Halfway between these two is your lowest point. And then you connect them. That's a basic sine graph. Starts at the origin, ends at the origin, halfway between. Now cosine starts at the amp. Starts at 1. Same idea though. Here's 0. Here's 2 pi. These are periodic graphs. They repeat constantly. So that means that wherever you start should also be where you end. So cosine starts at the top, ends on top, on the amplitude. Halfway is the lowest, and halfway between is where you cross. So a basic cosine graph, and you just connect the dots. So that's how you do a basic sine graph, basic cosine graph, right? You have to know sine starts at the origin, cosine starts on top. So now let's do a little fancier one. So graph of 4 cosine 2x. So first thing you want to do, you want to find the amp and the period. Amp is this, so 4. Period is 2 pi over b. b is the number for your x. So 2 pi over 2. So just pi. So in this case, again, it's a cosine graph, so we're going to start at the amplitude, which is 4. My period's only pi, so I'm end right here at pi. Halfway, cosine is the lowest, so we should go down to -4, halfway. And halfway between these two is where you cross. And then you can connect the dots. Oh, this is not going to be pretty. Something to that effect. Now, notice I haven't filled the whole graph up. They're going to want you to fill the whole graph up. So you just do it again. Okay, start here. What's another period? Pi plus pi, right? Add where you are plus the period gives me 2 pi. So I'm going to end right here. Halfway is my lowest. In between is where I cross. And you connect the dots. Hopefully better than me. There we go. So that's my crappy 4 cosine 2x graph. Let's talk about tan really quickly. So tan, I've never seen the master to graph it beyond using a calculator. So if you ever ask you to graph tan to me using your GDC, your graphical display calculator. A couple things to know. The period's different, very important. Period of a tan graph is pi over b, not 2 pi over b. So that might come up in handy if you're solving. So that's why that's important. But in general, again, they'll ask you to graph on a calculator. Just know you should be familiar with what it looks like. Here are asymptotes, where you don't see the line, are asymptotes. And the period is pi over b. So this repeats stuff. This is like pi over 2. The other asymptotes are pi length away, which would be 3 pi over 2. So little things like that. Again, most of the time it's on the calculator. They ask you to graph it. So let's get to some modeling with sine and cosine graphs. So first, let's talk about what all these things mean. This is a basic sine graph and a basic cosine graph. Right? It has everything in there. It has the vertical shift, horizontal shift, period, and amplitude. So a lot of times when I give you this, it's because there's a graph and we're trying to make it fit this data, right? It's the graph we're modeling. We want it to fit this formula here. Kind of like this. So let's talk about how to find everything. Now for me, the first thing I always find is the vertical shift right here. Now the way you find D, which is, we call this the principal axis. Right, it's the middle of your graph. If you want to think it's the middle. And you always find the middle the same way. You take that, you add the max plus the min and divide it by 2. That'll get you your vertical shift. And that's it. If I give you a graph, all we're going to do here to find the D value is we're going to add the max plus the min divided by 2. And that gets you the middle. Once you get the middle, it's really easy to find the amplitude. It's just the max minus the principal axis. That's all it is, right? If you know how high your graph is, right? If you know where the middle is, then you just get the max minus the middle, and that's your amplitude. There's actually a formula for it too, one I don't use ever, which is max minus min divided by 2. That would also get you the amplitude. So now we have D, we have A. B we know. Come on, we've been doing B forever. Right? B has to do with the period. Now it's not the period. Right? Period equals 2 pi over B. So if you can find the period, then you can just solve this problem. So for a lot of people, they also see it as B equals, if you like solve it, 2 pi over the period. But really I follow this formula and then I just kind of fill in what I need. Right? I figure out what the period is, like what I looked over here. It's like, oh, the period is pi. So you plug that in for the period here, and then you just solve. Cross multiply, divide by B. So that's all those things. Now C is a phase shift, right? Where does your graph start? So for C, it's actually the easiest, if you could see it. It's where does your graph begin? That's all you have to look for. Where does the graph start? Now you gotta watch out though. So if it's a cosine graph, right? If that's what the thing is, you're looking for, let's say I give you this, right? You're looking for that point right there where it's starting. That would be your C. If it's a sine graph starts in the middle. So if I give you a graph that looks like this, you gotta understand a sine graph goes up first, so it starts right here, right? Then it's the sine graph. That would be my C. Right? It's all about what type of graph you're talking about. Let's look up here. Let's say I was trying to figure out, I was like, y equals sine x minus c. I was looking for the c. It's a sine graph. Sine graph starts in the middle. So where would that be? It wouldn't be here because it's going down first. That'd be a negative sine graph. It'd be right here. Right? Because now the graph's going up and going down. So my c would be like 3 pi over 4. That's wrong. 3 pi over 2. Something to that effect. Right, so that's the idea of how you do C. Just figure out where the graph starts. If it's a sine graph, it should start in the middle, going up. If it's a cosine graph, it should start on top, going down. So that's the key there. But in general, if you're reading it, right, it's just a horizontal shift, right? It's like here, right? C value is the inside is x opposite. So in this case, we move pi over 4 units to the right. This one, right, inside opposite, we're going to move pi units to the left. So now let's actually use all this in a modeling technique. So right here, if I get them all in there. So in this one, right, so here's my graph from 0 to 12. They want me to fill this out. Now again, notice how the letters don't mean a thing. You gotta know them yourself. I know this is the amplitude, this is like the B, this is a horizontal shift, that's a vertical shift. From what I said last time, the easiest thing to find is the vertical shift. So I want to find this first. And what you do is you just take the max, take the min, and I'm going to go add them up and divide by 2. Let me find my middle. So I get negative 6 over 2 is negative 3. So my middle is negative 3, and I like to draw it. So that's my vertical shift there, which actually they didn't ask me about, but I'm going to put it down anyway. Set s equals negative 3. Very, very important. So now once you got that, the rest of it's easier. If I want to find the amp, I'm going from 2 to negative 3. That's my amp. So my P right there is going to be 2 minus negative 3, which is just 5. My amplitude's 5. You just count. So that's that one. My B here, B is kind of tough. Remember, I got to find the period of this thing. Now in this case, start here, go back to there. Pick a point and see how long it takes to repeat itself. So let's here, start at 1, goes up, goes down, ends right here at 9. So my period is, 8. 9 minus 1, 8. That's not my B though. Remember, the idea is period equals 2 pi over B. this part's 8. Right, my period date. So I have 8 equals 2 pi over b. Right, because again, the period is 8. I still got to find b. So then we just cross multiply both sides by b. 8b equals 2 pi, divide by 8. B equals, reduce it, pi over 4. So that's mine right here, pi over 4. And then r here. Remember if I talked about how you find r? This is a cosine graph. Cosine graphs should start on top and go down. So where do I find that in my graph here? It's not here, it's not there, right here. Right, it starts on there, goes down. So my r is just 3. So my graph should start. Right, that's where cosine graph starts. So my equation now, if I want to put this all together, it's going to be f of x equals, and they're not asking, but we're going to need it in a second, so I'm doing this. My p, which is 5, cosine of pi over 4, x minus 3 plus negative 3. A little awkward at the end, but it's fine. Okay, so let's move on. Here's this part. Hence, final solutions where the equation f of x equals negative 6. So, where does y equal negative 6 at? So let me see my graph here. Right, if I draw this, this is what they mean. I have 3 answers. And now here's the problem though. They do not cross nicely. Like that looks like it might be 6, but it doesn't cross nicely. So I'm going to have to use a calculator to do this. So I'm going to put this into my calculator. I'm going to y1. And then here will be my y2, because it's asking where does negative 6 equal all this stuff. Blah, 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 blah. So let's bring out a calculator. Look at that. Technology of the future. Or the past. It's like came out in like 1994. Anyway, y equals. Right, let's type this all in there. So again, make sure you're, oh, by the way, make sure we're in radians. Ooh, that would have been embarrassing. So, right, default always radians, so you graph in radians. So 5 cos, quick edit to put them all in there. So you don't have to worry about that. Now let's hit graph, because it's all in there. I get this. Now here's the thing we want to keep in mind. We always want to do. I should want to match my graph to that, my window to that. So right now I'm all over the place. So let me go fix my window. 0 to 10 for my x, and then look at my y, negative 10 to 5. Graph that now. See now how it matches that. And then I'm going to find my x-intercept. So again, we're going to go second, calculator, intersect. Let's get right there. Get close to the intersection, hit enter a couple of times. And I get 5.82, right? 36 figs. Do the same thing over there. Right, so we're looking for the x values. Here's a little hint. If you press up, you go on the other graph. It's a lot easier to move that way. If you press second, it goes faster. Get close, hit enter, and get 8.18. See, I wasn't exactly on line. I had to hit these values. I can't just eyeball it. The same thing with the first one there. I would go back, find that one, but I'm going to save you some time. So that's how you do those. The next one, the equation f of x equals k has exactly one solution. Write down the 2 possible values of k. So it's saying when I draw a line, it should only have one solution. So let's look up my thing over here. Where can I draw a line when I have one solution? Like right there, I have 3. I have 3. Here I only have 2. Right here. Right? At x equals 3, I have one solution. Only crosses one time. The same thing can be said down here. Right? I only have one solution at x equals 7. So there's 2 spots where I only get one solution, right? Because look at this blue line. I have 3 solutions. The green line, same thing. Right here I would have 2, but right there I have 1. So 3 and 7. So k could equal 3 and 7. So that's it for graphing. Now let's talk about how to solve things. So when we solve trig equations, it's all about knowing your unit circle. That's all we're doing. We're just going backwards on the unit circle. So I don't care if you do the table, right, with the 0, 1/2, 2 over red, 2 over 2, red 3 over 2, 1, then flip it, all that good stuff, or you know the triangles. Doesn't matter, you just gotta know that stuff either way. So the way we're gonna do this one is, the idea is you always want, anytime you're solving, you want to isolate the trig value. So you want to get this by itself. Now we're gonna leave the inside alone. We're going to get the sine part by itself. So let's divide by 2. Then you get sine of x over 4 equals rad 3 over 2. Now here comes the unit circle part. Do you know where sine equals rad 3 over 2? Again, I don't care how you know it, right? I don't care if you look at the table, if you do the triangle, if you're a freak, you have the unit circle memorized, right? It doesn't matter to me. You just got to know how to get there. Now, another thing with this is that it happens actually at 2 spots. 2 spots that way. You should have 2 answers because of this, right? All students take calculus. Now again, notice my value is positive, so I should have 2 answers. There's 2 places where sine's positive, and that is here and here, right? Quadrant 1 and quadrant 2. Now I'm gonna do this with the triangle because that's the way I like to do it best. So I know quadrant 1 and quadrant 2 should have 2 answers. Now the way I do with the triangle is that all students take calculus, so go TOA, so opposite of hypotenuse. So this is rad 3, this is 2. Opposite's rad 3, hypotenuse is 2. Same thing over here. That's why I do it, because I know sine is opposite of hypotenuse. Here's my angle. Opposite's rad 3, hypotenuse is 2. So then from there, if I'm doing the triangle method, I have to have that memorized. What is opposite rad 3? 60. It's 60. Again, if you're doing the table, rad 3 over 2 would be at 60. So you just have 60, 60 there. And now, those are my 2 answers. I got 60 if you're doing in degrees. And then over here, this is 180. 180 minus 60 would be 120. Right? You're 60 short of 180. So my answers would be 60 and 120. Now let's do this in radians though. So in radians it's memorization. So 60 is the same thing as pi over 3. This would be pi over 3, right? So this is pi. Common denominator is 3 over 3. And you're 1 short. You haven't got there yet. You're 1 away from that. So 2 pi over 3. So my answers are x over 4 equals pi over 3 and 2 pi over 3. Now if you notice a couple things here, I'm not done. There's x over 4. What does that mean? Multiply both sides by 4. That's one thing. Also, notice it wants 0 to 10 pi. I only got pi and 2 pi over 3. How do I get more of them? Well, anytime they want more than the normal one, you have to go around a full circle. So I have this, go around a full circle, which means add 2 pi. Because this rotates and rotates and rotates. So common denominator, 6 pi. So 6 pi plus pi is 7 pi over 3. And then the same thing over here is this 2 pi over 3. Go around a full circle, plus 6 pi over 3. And I get 8 pi over 3. And I think if I go around again, I'll be too big. I actually might be too big already. Let's multiply this by 4. Into all of them, I'm going to get 4 pi over 3, 8 pi over 3, that's 28 pi over 3, and 32 pi over 3. Now I only want between 0 and 10 pi. So that's good. That's less than 10 pi. That's less than 10 pi. 28 over 3 is like almost 7. Sorry, 9-ish. It's still good. But 32 over 3, that's more than 10, right? That's almost like it's almost 11. So that is not within the domain. So my answers are this. So again, we're going to do a couple more, but the general idea is get the sine by itself. So in this case, I got sine and equal rad 3 over 2. Ignore the middle. Ignore the inside. Let's worry about that at the end. So where does sine equal rad 3 over 2? Quadrant 1 and quadrant 2. I don't care how you solve it. So you should get 60 and 120 in degrees, but we're doing radians here. Now you get credit either way. IB gives you credit, degrees, or radians. But I want to do it in radians. So I did in radians. So I figured out radians, and I had this. Now what do you do with the inside? Now you can multiply it by it. But once you get your answers, then you can solve the inside part of it. The hard thing was they wanted between 0 and 10 pi, so I had to keep on going around again. So anytime they want more than normal, just add 2 pi, or 360, because that's a full circle. So that's that one, right? A little tough. It's another one, same concept. Now this one is the factor. Look at this. 2 sine squared minus sine minus 1. Right, it's a quadratic equation. It's a quadratic. It's squared. So the trick is ignore the signs. Make it this. Now we know how to solve a quadratic. set equal to 0, and factor. Now we got to factor that. Again, I don't care how you factor it. I tend to factor it this way. Find the two things that multiply to get 2 bad to get negative. Multiply to get negative 1 bad. Two things that multiply to get negative 2 bad to get negative 1. Negative 2x and positive 1x. Plug it in for the middle. These have a 2x in common. X minus 1. These have nothing in common, so pull out the 1. There's always a 1 in common. Hey, these match. So we get that. So you just put the sign back. It is sine x minus 1 to sine x plus 1 equals 0. We split and solve like a normal math problem. I isolate the sign by itself, so I get sine of x equals 1. Get the sign by itself, sine of x equals negative 1/2. Now this we're gonna solve just like before, right? I don't care how you solve it, but solve just like before. All students take calculus. Notice my thing's negative this time. Sine's positive at A because everything's positive at A, and at S because that stands for sine. So negative would be the bottom two. Again, I don't care if you do this with the chart or with the triangles. Either way, you gotta figure out where it's negative because you're gonna have two answers. So I'm doing the triangle way. Sine is opposite of hypotenuse. So negative 1 over 2, negative 1 over 2, opposite negative 1. And then that, what's opposite 1? For me, it's 30. Right, opposite 1 is always 30. Again, I want to do this in radians. So 30 is saying pi over 6. So how do I do this? Well, here's pi, also known as 6 over 6. And we're going to go, remember we always start here, we're going to go this way. So you're going a little bit further than 6. So this will be 7 pi over 6. This is 6 over 6. Another 6 over 6 would be 12 pi over 6. And you're a little short. You haven't got there yet. You're right here. So 1 less is 11 pi over 6. So those are my two answers from this one. From where sine equals negative 1/2. Again, I don't care how you do it, but you got to know how to do it one way. Now this one's a little trickier. You can 1 plus or minus 1 and 0 are special. It's the unit circle. They don't have a chart. They have points. So you remember where sine's y at. Here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine is sine e. So that's the y value. So it's right here at pi over 2. And those are my three answers. Pi over 2, 7 pi over 6, 11 pi over 6. Again, IB doesn't care if you do degrees, which would be 90, 210, and 330. Either way is fine. And if that wasn't tough enough, let's go a little bit tougher. So now we have to know some trig identities too. So some of them we should already know. Tan is sine over cosine. This is all the way it is in your formula sheet. So tan is sine over cosine, very important, right? Especially when we do unit circle stuff. Now here's the one. Sine squared plus cosine squared equals 1. They love to ask a question with this in there. It's just understanding what that means. But what also important is remember there's two more things that are equal to this. All we do is let's solve. Again, your formula sheet comes like this, but you get to write on it. Once you get it, feel free to write on it. So in this case, get sine by itself, right? So subtract cosine for both sides. You get sine squared equals 1 minus cosine squared. Because this is equally as important, if not more so. Same thing with cosine. Get cosine by itself. Subtract sine squared from both sides. Cosine squared equals 1 minus sine squared. Right? Those are just as important as sine squared plus cosine squared equals 1. You're likely to see this as you will to see these two. So once you get your formula sheet, write those down to solve for each one. Double angle formula. General idea here, guys, is once you see one of these, you're most likely, unless it's a solving problem, you're most likely going to change it to one of this. If I see sine 2 theta, unless I'm setting solve, you want to switch it to this and try to do it. Same thing here. If you've seen cosine 2 theta, unless it's like one of these solve these equations, you can rewrite it to one of these. How do you know which one to write it to? It all kind of depends. If your equation has all cosines and change it to a cosine thing. If your equation has all sines, change it to the sine one, right? They're all the same. Doesn't matter. So let's do a couple more examples. So solve a couple of tangent problems. So again, same idea here. Notice how it's tan of something inside. Leave that there. Don't worry about it. Let's just solve this. Where does tan equal rad 3 over 1 at? So, same thing. All students take calculus. Again, I don't care if you triangle or the chart. Notice how tan is positive here. So where's tan positive? They're always positive in quadrant 1. And tan has a T, so it stands for tan down there. Sorry, I have a hard time understanding if you don't understand that. So we have this, right? Again, if you need a chart, triangle, I don't care. I'm going to do a triangle, so TOA. Opposite of my angle is rad 3. Adjacent's 1. Opposite's rad 3. Adjacent's 1. Now, since I'm doing a triangle, I know I have this memorized. Opposite rad 3 is big. I get the 60. So 60 degrees. And again, if you're doing the triangle way, or either way, you have to know that 60 degrees is the same thing as pi over 3. Because again, especially since it's pi over 4 right there. And then this is pi. Common denominator though, make this 3 over 3. And we went a little bit past it. I want to get to here. So go a little past it. 4 pi over 3. So those are my two answers. So what does that mean? That means this is going to equal pi over 3 and 4 pi over 3. How do I solve this? Well, just math. Add pi over 4 to both sides. That part kind of sucks. You have to do common denominators, but pi over 3 plus pi over 4, common denominator would be what, 12? Let's do it over here. So I have pi over 3 plus pi over 4. I want to add them, I have to do common denominator, so I'll make this 12. Multiply this by 4 over 4. Make that 12. Multiply this by 3 over 3. So I get 7 pi over 3. 12. And then sending over there, 4 pi over 3 plus pi over 4, common denominator stuff. Right, to get from 3 to 12, you multiply by 4. So I get 16, so I get to be 19 pi over 12. Right, some basic arithmetic right there with our trig function. Right, but what was the main thing? Try to get the trig variable by itself. If there's something inside, just ignore it till the end. Solve this the way you would solve it. So where does tan equal rad 3 at? Well, it's positive, so quadrant 1 and quadrant 3, because all students take calculus. Rad 3 over 3, so I knew it was 60, sorry, which is pi over 3. Sending over there. And then once you solve it, solve the inside part. Add the pi over 4 to both sides. This is the next one. Next one's tricky. And we're almost done. So next one gives you this. 3 sine x plus rad 3 cosine equals 0. Now this is tough because I don't have a formula. If one of them was squared, I could do something, but all I have is single things. So the trick here is and it's definitely a trick. Is to try to make, that's so trick. Is try to make tan. Because remember, tan equals sine over cosine. So I'm going to try to make tan. I'm going to put them on separate sides. 3 sine x equals negative rad 3 cosine x. Right? It's subtracted rad 3 cosine from both sides. Okay, now, how do I make this a tan? Remember, tan is sine over cosine. So I'm going to get the sine on top. So let's divide both sides by cosine. So this becomes 3 tan x equals negative rad 3. Divide by 3. Tan x equals negative rad 3 over 3. So that's my tan. Now again, I don't care how you solve this. Chart, triangles, blah, 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 blah. Now if I'm going to solve this, where does tan is negative at? All students take calculus. Tan is negative. It's positive at these two, so it must be negative at the other two. Now this is a little tricky because this is rationalized. Normally this is the same thing as saying this. But they rationalized it. So that's a rationalized version. Honestly, you generally won't see this on IB test because it's rationalized. But opposites rad 3. Adjacent's 3. rad 3, 3. Again, it's a little tricky. Normally, I would say rad 3 is 60, but there's a 3 here because they rationalized. This is actually only going to be a 30-degree angle. Rad 3 is smaller than 3. Sitting here, it's going to be 30 degrees. So no, a little funky because it's rationalized. That's why we hate rationalization. Anyway, 30 degrees is pi over 6, which makes this pi, common denominator, 6 over 6, 1 less, 5 pi over 6. So that's this answer. Sitting over here, this is 6 over 6. Go around again, 12 pi over 6. And then 1 less would be right here. Can't draw a straight line for the life of me. 11 pi over 6. And those are my two answers. Again, a little tricky, but that's the idea. Hardest part for me was the fact that, well, right, anytime you have sine, you just have basic sine cosine, that's tricky. You got to try to think tan, sine over cosine. So move them across from each other. Try to get, then divide by cosine. Try to get the sine over cosine, so you get tan. Then just solve it. So my two answers are these. Let's go to the next one. The last one is tough. Here's a classic IB problem when they want to be tough with trig functions. So cosine 2x equals 3 cosine x minus 3 minus cosine squared equals sine squared. I got to solve this. So first step, let's try to make everything into a cosine. Right? You notice how there's like all cosine things? Let's try to make it into a cosine. So this cosine 2x, look at your formula for it. It equals any one of these three. I'm going to use this one because it only has cosine. So 2 cosine minus 1. That one's fine. That one's fine. Cosine squared is in cosine, so I'm going to let it go. Sine squared. Remember what we said sine squared equals? So it's one of those things we added in. Sine squared equals 1 minus cosine squared. So this is 1 minus cosine squared. So let's bring everything else down. Now it's a fancy, funky problem, right? Let's set equal to 0. Actually, before that, let's simplify a little bit. That's 2 cosine squared minus cosine. That's just cosine squared. I have -1 and -3. So minus 3 cosine x minus 4 equals 1 minus cosine squared. Okay, now it's just algebra, right? I simplified it a little bit. Set equal to 0. Let's add cosine to both sides, cosine squared to both sides. Subtract 1, subtract 1. I get 2 cosine squared x minus 3 cosine x minus 5 equals 0. Now I got to solve this. So I got to factor. When we talked about, make it easier. 2x squared minus 3x minus 5. 2x squared minus multiplying it by -5 equals -10x squared. 2 to multiply it, that's me -5 and positive 2x, right? So plug that in for the middle. These have an x in common, 2x minus 5. These have nothing in common. I mentioned that before. Put a 1 out there. They have nothing in common. Hey, these match. 2x minus 5, x plus 1. Okay, so this is going to be 2 cosine x minus 5, cosine x plus 1. Split it, 2 cosine x minus 5 equals 0, and cosine x plus 1 equals 0. Add 5 divided by 2. So you get this, cosine equals 5 over 2. Now that's like 2.5. And we should know by now, so we should know that cosine, you can't solve that, it's too big. Cosine and sine, think about their basic graphs. They can only be between 1 and -1. So if you ever get something that's too big, that's bigger than 1 or less than -1, you can't do it. So no solution here. Now let's go to this one. Cosine x equals -1. That's a trickier one. Remember, it's on the unit circle. Because it's one plus or minus 1 or 0. It's on the unit circle unless it's 10. And cosine, sine A, sine's at y, so cosine must be x. So that's right there. So that's at pi. So my answer to that big old mess was just pi. Okay, one last one. Good news, it's my favorite. So I love the type of question. Ivy loves to ask it too. So it's a win-win. And the question is, if A is an obtuse angle in a triangle and sine of A equals 5 over 13, calculate the exact value of sine of 2A. So this is one where sine of 2A, I'm about to change it. I'm not gonna use sine 2A. We'll talk about it. Sine 2A is a formula. Go up here. Sine 2A equals 2 sine cosine. Again, pretty much you always change if you see sine 2A. Only time you don't if it says like solve sine 2A equals like 1/2 or something like that. Then you just solve this like you normally would and then divide by 2. But in this context, 90% of the time, you gotta change it. Sine 2A is 2 sine A cosine A. That's what I'm gonna use. So how do I do this part? Well, it's an obtuse angle. That's code for quadrant 2, right? Obtuse means bigger than 180. So here's like 0, here's 180. Obtuse means bigger than 90, sorry. Right? Acute angle is quadrant 1. Obtuse angle is quadrant 2. It's this like little code. It's a cute code. And then how do you tell quadrant 3 or quadrant 4? They have to tell you. There's no shortcut to that. So you have a triangle in quadrant 2. That's all that means. And it's sine A, right? So remember sine is SOHCAHTOA? So opposite's 5. Hypotenuse is 13. That's my triangle. Now it's a triangle. How do you find the missing side? Quadratic Pythagorean theorem, right? 5 squared plus b squared equals 13 squared. Honestly, it's one of the ones you should know already. It's going to be 12. But I'll go through the paces. B equals 12. Plus or minus 12, actually. And this would be 12. But since you're going to the left, it's a negative 12. And that's all I need. Right? Because if I'm doing sine of 2A, all I can do is plug into this thing. So it's 2 sine of A. Sine of A is 5 over 13. So 5 over 13. Please don't do the thing I hate where people plug in 5 over 13 for the A part. That's not A. The whole thing is 5 over 13. Look at it. Sine A equals 5 over 13. Same thing with cosine, right? Cosine A. Cosine SOHCAHTOA. It's that over that. So 5 over negative 12. It's just 2 over 1 if that helps. Now all we're going to do is multiply, and I get 2 times 5 is 10. 10 times 5 is 50. And then 13 times 12, whatever that is, I can't think of it right now. It's 144 plus 156. And a negative. And that's the answer. That's all you have to do. Don't do the thing I hate when people do, oh, sine 2A is just 2 times this. That's not what it says. It's not 2 sine A, right? It's sine 2A. Very special. Rewrite it, and you get this, and you get that. So that's the idea.